So we'll start off with microgeneration. The first one we'll look at is photovoltaic cells. Now these are more or less fit and forget technology. However, the inverter is unlikely to last more than around 15 years, I would imagine. And so what the inverter is it takes the electricity that comes from the photovoltaic cells, which is at a very low voltage, and it produces that goes into the inverter, and out the other end comes a very small amount of mains current and mains voltage. That's 13 amps and 230 odd volts electricity, which will then be okay to drive most internal domestic appliances. Now, photovoltaic technology has come on leaps and bounds in the last 20 years. They used to be completely rubbish, but now actually even just a 1 or 2 square meter array is enough to provide a sensible quantity of electricity for your property. The installation costs have also been cut in half thanks to some recent central government grants that were provided. Now these, not grants, but subsidies. Some of the grants helped for this, but mostly it was subsidy, which was excessively generous, and the government ended up caught out a bit by this, having to provide these subsidies when a lot more people were getting photovoltaic cells than fitted to their house than they expected. And it got to the point where people were actually leasing out individuals' roofs in order to provide power for the national grid, and the profit margins were such that it made that a sensible business exercise. So the capacity we've got at the moment, June 2013 is the last statistic I picked up, which was 2.4 gigawatts. It'll be significantly up since then, and usually it's through solar panels on individual residential properties. So what you have is you've got a smart meter in the property which rotates the normal direction, saying that as you use up electricity, as your bill increases, but then what it effectively does is when you stop using up more electricity than you're generating, it then winds the dial in the opposite direction and effectively reduces the cost of your bill. So if you went away on holiday for a couple of weeks, then you're going to have a net negative electricity bill for that period. And the idea with this having lots of individual points for generation of electricity is also much more effective in that it doesn't rely on a few key power stations to generate the nation's power. It's a lot more sustainable source of power generation. The thing that really clouds the issue for photovoltaics is if you're going to have a battery. So the smart meters is the way that it's usually done, but if you had a battery for more remote locations where you've got these photovoltaics, then the batteries need replacing reasonably regularly. They're usually lead acid, and they're not very good for the environment. So that can cloud the eco-credentials quite a bit. But at 5 to 8K, they're relatively cheap to install, and they save £260 a year. So just pause this video and spend a couple of seconds with a calculator working out just how many years you've got to have your photovoltaics on your roof to pay off your £5,000 to £8,000 investment to get them fitted. It's quite a few years, and so this sort of thing's only really worthwhile, along with most of these other measures I'll show you, if you are going to live in the property for quite a long time. Otherwise, why would you put in the upfront investment?